the tangent to the circle, right? Well, because the reason why they gave this though is because we should see in the first one, however, that this line is cutting through the circle, right? So obviously, well, if you want to find these 2 points, that means you're going to solve a set of 2 simultaneous equations, which we have done from like grade 11 already. Okay, and this one, obviously, if you maybe find the equation of this and find the equation of that, if you try to solve this simultaneously, you will get no solution. So that means this line has got nothing to do with the circle. Now, this one is the one where the line meets the circle at only one point. Okay? This is the tangent. Only meets the circle at this point only. That's the one that we are more concerned about today. Alright? So, if you can do something like this, okay, right? So this line to that's a radius, isn't it? A radius can touch any part of the circle if it wants to. Okay? So, if you still remember, in Euclidean geometry, there's a theorem which says this. The tangent and the radius meet at 90 degrees. Yes. Remember that theorem? Yes, they're perpendicular to each other, okay? So basically, if I draw this tangent and I draw that, this angle here must give me a 90 degree. Okay, let's see. Okay, so this angle here must give, whatever. But you can see what I'm saying, isn't it? Okay, so that is 90 degrees. Now, when we started analytical geometry, we learned something about perpendicular lines, isn't it? The gradient of this line and the gradient of that tangent, because they're perpendicular to each other. If you multiply the gradients, they must give you -1, isn't it? That's what we learned when we started analytical geometry, right? We've been learning that from like grade 10 already. So that is what we're going to be using to find the equation of the tangent to the circle at that point. Okay? So let's look at an example then. Okay, let's clear that. Okay, so let's look at an example, okay, of how this is going to work. Right, so the equation of a tangent touches the circle at a single point. The point where the two touch is called the point of contact. Okay, that's what I've been just saying. From grade 11 geometry, we know that the tangent to a circle is perpendicular to the radius and the diameter at the point of contact, right? So that's what I've just explained already, that the angle here is 90 degrees. Okay, so now here's a question. Find the equation of the tangent to the circle x squared plus y squared is equal to 50 with point of contact that. Okay, I know my circle is not going to be like very, very perfect, but I will try. Okay, right. X squared plus y squared is equal to 50. So this is a circle. What's the center of the circle? The center of the circle. Remember, you just pick it up from the equation.
The center.
Mm-hmm. Is it not 0, 0?
Oh.
Because it's x minus 0, y minus 0, right? That's why it's like that. Remember the center of the circle, x minus a, y minus b, okay? So obviously the a and the b are zeros here, that's why it's only x squared. So that circle is the center at the origin here, 0, 0, right? It has a point of contact, -7 and -1, so that's probably some point there, -7 and -1, right? So obviously that's going to make a circle. Okay, right. So they want the equation of the tangent that passes through this point, right? So the tangent must pass through this point here. That's the equation of the tangent that you're supposed to look for, right? Okay, so there it is. Now, this center is 0, 0. That point is 7, 1. So if I draw this line, it's easy for me to find the gradient for this line. You can find it, isn't it? Right? And if I find the gradient of this line, then it's easy for me to find the gradient of that line. Remember, for you to sketch a straight line, what you need one point on the line and the gradient. That's what you need, right, to find the equation of a straight line. Okay, so we can find the gradient there. So let's find the gradient of the radius, which is equal to what? Remember, it's changing y, so it's 0 minus negative 1 over the change in x, which is 0 minus negative 7. Okay, you can use a calculator if you want, but I can already see this is 1 over 7. Right, now I need to find the gradient of the tangent. Because remember, if I take the gradient of the tangent multiplied by the gradient of the radius, my answer must be negative 1. Why? Because the tangent is perpendicular to the radius. You don't have to give a reason, because this is not Euclidean. Euclidean is the one that you have to give reasons. This now, you don't have to. Okay? So, the gradient of the tangent, I don't know it, but I know the gradient, that one is negative 1. So it's positive 1 over 7, which is negative 1. So all I just have to do is divide both sides by 1 over 7. Divide by 1 over 7. So that the gradient of the tangent is what? Negative 1 divided by 1 over 7. Your calculator must give you negative 7. Check. The calculator should give you negative 7. Okay, so now I know the gradient and I know one point on the line. It's very easy to find the equation of the straight line. Okay, there's two methods that we normally use. Okay, so to find the equation of the straight line, I can now say, okay, this line is y equal to mx plus c, right? Remember, m is the gradient, c is the intercept. So that means this line y is equal to negative 7x plus c. Why? Because we know that that's a gradient. Okay. Now I need to find c. So I'm just going to sub in this point, negative 7 and negative 1. Okay. So sub that point in. So I can just sub that point in, which means where there's y, I put negative 1. Where there's x, I put negative 7. Okay, so we can just simplify that. Negative 1 is equal to positive 49 plus c. Take the 49 over, so that means c is equal to negative 50. Is that not so? It is, right? And then if c is negative 50, then obviously the equation of the straight line is going to be y equal to negative 7x minus 50. Okay, so determine the equation to the circle of that. Okay, now this one is a little bit different. X squared minus 2x plus y squared plus 2y. It's very difficult to get the center from there, isn't it?
So must you put it in standard form?
You have to put it in standard form by completing the square. Okay, so we have to put this one in standard form. So let's do that. Oh, okay, so this is sorted already. So let's just get into completing the square then. This is my preferred method. X minus, so this 2 obviously divided by 2 squared minus the 2 over 2, and you square that, plus, and then this y plus, because there's a plus there, that 2 over 2 But when you do the one outside the bracket, it's still minus. Okay? And then this is equal to 11. So now we have to simplify this. Okay? So this becomes x minus 2 divided by 2, that's 1 squared, minus 1 squared, plus y plus 2 over 2, that's 1 squared, minus 1 squared is equal to 11. Okay, 1 squared is obviously 1. 1 squared is obviously 1. So why don't we just take this over to the other side already? Okay, so x minus 1 squared plus y plus 1 squared is equal to 11 plus 1 plus 1.
So you don't say 1 squared. Yeah, because it's 1 squared.
1 squared just gives you 1 anyway. So no need for that. Okay, so now our final equation is this: x minus 1 squared plus y plus 1 squared is equal to 11 plus 1, that's 12 plus 1, that's 13. Remember, 13 is a radius. Okay, we don't really need the radius right now for this question. We need the center. The point of contact we have already. So the center is the one that we needed. And now that the equation is in a standard form, we can now find the center. Okay? We couldn't do that before. It's in standard form now. So we can find the center. So the center is this negative. Remember, the signs change. So the negative 1 becomes a 1 here. And the 1 becomes a negative 1 there. Okay. Right. So now I have the center and the point of contact. It's now easy to find the equation, right? Because this center and this point of contact, that's where I'm going to get my gradient from. We don't really need to actually sketch this circle after all. Well, you can sketch it if you just want to have fun with it, but it's not really necessary. Because you're just going to do this. Okay, I still need the point of contact in the picture so that I can find the gradient of the radius is what? Changing y, so that's 1 minus negative 1. Remember the y2, y1. Divided by changing x, so that's the negative 2 minus 1. Right. I think here you're going to get negative 2 over 3. So now to find the gradient of the tangent, remember, to find the gradient of the tangent, this one, I must multiply with that one to get negative 1 because gradient, because radius and tangent are perpendicular. So that's why the gradients must multiply to negative 1. Remember the theorem? Okay. So the gradient of the tangent, I don't know it, but I know that it's negative 2 over 3 is equal to negative 1. So for me to find the gradient of the tangent, I'm just going to say negative 1 divided by negative 2 over 3. Yeah, I can just do it like that. It's fine still. And the nice thing about you, if you've forgotten how to work with fractions, you can just use the calculator. Easy. Like sometimes, why not? Just use it. Okay? Yeah, because in the exam, you don't have time to really scratch your head and find solutions. You know, you only got 3 hours to do that paper. Okay? But after that, so this should be what? 3 over 2. Okay. Now, we can now put it into the equation. Now, remember, the point that you're going to use for your equation is the point of contact, that negative 7 and negative. It was negative 2 and 1. Yes. That's the point that you're going to use. Okay? So, let me use the other method now. This one of using this formula here. Y minus y1 is equal to m of x minus x1. Remember this formula, you have it in the back of your paper.
Yes, sir.
Okay. So, y minus, the y coordinate of that was 1. The gradient here is 3 over 2. X minus x1, the x coordinate is -2. So we're just going to simplify this equation and make y the subject. So y minus 1 becomes equal to 3 over 2 by x plus 2. Okay, multiply everything with the brackets. So y minus 1 is equal to 3 over 2x plus 3 over 2 times 2. If you do it to the calculator, you're going to get 3. Okay, and then take this 1 over. So y is equal to 3 over 2x, yes, plus 4. It's done. Right, as like a homework task, obviously with your homework, at home, I want you now to take this gradient, that point of contact that you had, use that other method and see if you're going to get the same equation.
So I did have an equation, the y.
mx plus c.
That's why I got that.
Okay, so if you get the same thing, it means you did it right. Okay. Okay, so with this, we can now get onto the exercises.